In continuation with the previous session, we need to identify our non-manifold edges. So when we design the component, we have to take care about their holes identification and also the manifold edges. Manifold edges in the sense, when we design the component, that meshing will not be done by its manual process. So we may have some it can able to generate the errors when the edges getting converted into the form of design format, and it cannot able to do the editing by using the measurers, but with the help of watertight geometry we can able to ensure it, and also it can able to prevent the failed prints. So that is why we have to identify the manifold edges, and the second thing we need to do the measurers, and the third one we have to ensure the watertight geometry, and the fourth one we have to prevent the failed prints. So based upon these four aspects, we have to identify the edges and as well as the measurers, and also you can able to give the watertight geometry so that it can prevent the failed prints. The same concept which has been repeated for while doing the component design and as well as when it was doing the error checking. Okay, and part orientation. So generally in the part orientation, if you're going to draw the diagram, but with respect to the support structure, it has been keep on varied. Okay, this support structure, it can able to build the direction either in the part form of format or either it may be overhead angle format. Okay, but their supports will can able to generate only with respect to the edges, not with respect to the corners. But the corners as making with the help of the feature which has been operated in the software, but the contact angle which is keep on changing with the part. Okay, either it can be the pot can be placed, either it may be from 0 degree to 35 degree or 0 degree to 45 degree, which we have normally we use it in this format, but this can be added as an subtract. Okay, that subtract it can be making with the help of overhang angle, and it can generate the support structure that is 0 to 45 degree, but their direction of building has keep on changing with respect to 65 degree, and it can keep on adding with the help of the part, and also while doing the assembly it can able to record only in the particular direction, but not all the time the part can able to support in the placing angle, whether it is keep changing with respect to the particular material parameter or not, and based upon that we may come to the decision, and so that it can able to reduce the print time and as well as the materials usage. So it can able to determine the build direction along with the support. So that is a primary objective. In support structures, in this slide you may see there is a meshing images in this diagram, and here we have to mention, while we are designing the component, we have to mention the dimensions, and also we have to mention the layer thickness and what kind of material it is and which parameter we need to consider while designing the component. And also there is a point distance, there is a distance between the laser exposure points, and also the hatch distance has been mentioned, but the distance between the laser scanning vectors which is keep on varying with respect to the space between the layers, since it is a layer by layer manufacturing. Therefore the layer by layer manufacturing which creates a lot of space in between the form of material usage. So that is that complex features and the overhangs which has keep on following with this diagram, and it can able to minimize the material usage, and also it can able to remove the post printing process, and finally it can ensure the stability during the printing. So with respect to the complex features, the stability has been formalized, and also it can able to easily track the shape of output which can be generated in the printing. And if you are going for the model slicing, the second stage of additive manufacturing is slicing. So since we begin the component by designing using the CAD software, And once the design has been done, and the second the step of the additive manufacturing, we have to do the slicing. So here the first and foremost step, we need to convert the 3D model into the layers, because the layer by layer manufacturing only it can able to do in the complex part. Okay, and it can able to define the 3D model into the thickness and the speed according to the parameters we can able to design the component. And the third one, it can able to generate the tool path, which means where exactly has been located to generate the tool path, and defines the direction of the movement of the tool path so that the tool involves in the manufacturing. Okay, so commonly used in the slicing software is Prusa Slicer, Simplified 3D, Cura, and also the Tinkercad. So these are the major softwares which is commonly used in all kind of designs. That is why we need to primarily aiming to make the 3D model with the help of the layers, and also the layer thickness and the speed can be able to generate only by defining the tool paths. Okay, and we can able to use the software in Prusa or some other softwares. Okay, we will continue next session. Thank you. So that is why we have to mention in these parameters.